Implementing Kubernetes K8s effectively involves adhering to several best practices to ensure scalability, reliability, security, and efficiency. Here are some key best practices for Kubernetes. Use namespaces. Use namespaces to logically divide cluster resources. This helps in organizing and isolating resources for different teams or applications. Resource requests and limits. Define appropriate resource requests and limits for your containers. This helps Kubernetes scheduler to make efficient decisions about where to place pods and ensures that resources are allocated fairly among pods. Health probes. Implement liveness and readiness probes for your containers. Liveness probes determine if a container is healthy and should continue running, while readiness probes determine if a container is ready to serve traffic. Horizontal pod auto-scaling, HPA. Use horizontal pod auto-scaling to automatically scale the number of pods in a deployment based on CPU utilization or custom metrics. This helps in efficiently utilizing cluster resources and handling fluctuations in traffic. Deployments. Use deployments instead of directly creating pods. Deployments provide declarative updates to pods and manage rolling updates and rollbacks effectively. Secrets management. Use Kubernetes secrets to store sensitive information like passwords, API keys, and tokens securely. Avoid hard-coding sensitive data in configuration files. Configuration management. Use config maps to decouple configuration details from your application code. This allows you to manage configurations independently and update them without changing the application code. Logging and monitoring. Implement centralized logging and monitoring solutions like Prometheus, Grafana, or ELK Stack to monitor cluster health, track application metrics, and troubleshoot issues effectively. Pod affinity and anti-affinity. Use pod affinity and anti-affinity to influence the scheduling of pods and control how pods are spread across nodes or co-located on the same node. Security policies. Implement Kubernetes security policies to enforce security controls such as limiting pod privileges, restricting network access, and defining security contexts. RBAC. Use role-based access control, RBAC, to define granular permissions and restrict access to Kubernetes resources based on roles and responsibilities. Backup and disaster recovery. Implement backup and disaster recovery strategies to protect your data and ensure business continuity in case of failures. Versioning and upgrades. Regularly update Kubernetes versions and associated components to leverage new features, performance improvements, and security patches. Documentation. Maintain comprehensive documentation of your Kubernetes cluster, including configuration details, deployment procedures, and troubleshooting guides. Community resources. Stay updated with the latest developments and best practices by actively participating in Kubernetes communities, forums, and events. By following these best practices, you can effectively manage and operate Kubernetes clusters, ensuring high availability, scalability, and security for your applications.